Solving problem 9 from the 2024 F equals MA exam. When a car's brakes are fully engaged, it takes 100 meters to stop on a dry road, which has coefficient of kinetic friction. Mu of k is 0.8 with the tires. Now suppose the first 50 meters of the road is dry and the rest is covered with ice, with mu of k equals 0.2. What is the total distance does the car need to stop on the icy road? That's what it's asking. So we have our original road, where we can say that this is the full distance it takes to get to a stop. D is 100. We know that. And it's having the distance, but adding this distance x, where it's on ice. So we know that this is 50. But first, we can write the amount of energy dissipated by friction. So for this one, energy dissipated by friction is going to be, this is simply F of mu, or F of D, which is going to be mu of 1 times mgd. Now, we can also do it for this one, energy dissipated by friction. Well, this is a bit harder because this is F of d over 2 and then F of x, but if you use the formula, this is just mu of 1 mgd over 2. And then you have to add the energy dissipated by friction on the ice, which is distance x. So this is mu 2 mgx. Since we know that the car slows down to a stop when velocity is 0, the energy dissipated by friction when the car slows down to 0, so we can set these equal to each other. So we know that mu of 1 mgd, the first road, is equal to mu of 1 mgd over 2 plus mu of 2 mgx. There are common terms in this equation we just derived, but we can subtract this from both sides to get that this side is mu of 1 mgd over 2. Because if you subtract a number, because if you have half of a number and subtract it from the number, you get half of it. This is equal to mu of 2 mgx, where we can cancel out the mg components and then divide both sides by mu of 2 to get x 1 over 2 mu 2 of 2. We now have that value of x, where we can say that the total distance traveled on this, the second road, is equal to d of 2 plus x. So d over 2 plus x, we factor out of d over 2. This is 1 because of this. And then we plug in x equals all this, factor out of d of 2, and then this is just the u of 1 over mu of 2. And then, yeah. Now we can start plugging in values. We know that d is 100, the original distance is 100, so this becomes 50. Mu 1 is 0.8, and mu 2 is 0.2. So this just becomes 4. So 1 plus 4 is 5. 5. So basically, our total distance we need for the car to stop is 50 times, I should write it here, is 50 times 5, which is equal to our answer of 250 meters for this problem.